This is the Architect Exam Podcast, the official podcast of the Young Architect Academy.
Hey everyone, Emily here. Today we're diving into a topic I'm very passionate about, architectural specifications, and the most common mistakes we all make with them. And when I say we, I definitely mean myself. We all make mistakes, and I'm about to list 10 of them, and I have made just about every single one of the mistakes I'm about to list. I have copied and pasted specs on projects before, and inevitably it's led to issues down the road during construction. And let's just say that the contractors always have some very colorful questions for me when that happens. Making that mistake really can highlight my oversight and my lack of review of specifications before sharing them with a contractor for a project. So I've also been on the receiving end of these mistakes, trying to figure out why the architectural drawings may show one thing when the specifications show another. For example, I've seen drawing sets that have one door type shown in the drawings, but then something else is described in the written specification. It really leads to a huge headache trying to figure out which one's the right answer, or just getting in touch with the team that put together those specifications and drawings. And that back and forth is completely avoidable. Doing it right the first time can help you to avoid hunting down information and looking for the correct answer later. So having these experiences myself is exactly why I decided to create this episode. Specifications might not be the most glamorous part of architecture, but they are absolutely critical to bringing our designs to life and making our projects a success. So doing it correctly is very important. When specifications are used correctly, it's a great preventative measure and a communication tool to your contractor and to building material and product suppliers as well. So today I'm sharing my top 10 specification mistakes that architects make, and more importantly, how to avoid them. Whether you're a seasoned pro or just getting started with this, I guarantee that you'll pick up some useful tips here today. This episode specifically is why we created our CDT 101 course at the Young Architect Academy. We help architects to understand the value of specifications and avoid these common pitfalls. The Construction Documents Technologist certification, the CDT certification, is essentially a masterclass in how not to make these mistakes. So keep that in mind. So let's jump right in. I'm going to start with mistake number 1, which is poor coordination between drawings and specifications. Again, this is the number one mistake. I see it all the time, and that is just the lack of coordination and cross-referencing the drawings and the specifications. It inevitably leads to confusion, and it leads to a disconnect between the project design intention and the execution of that design. And so many of us have been there. We've seen a drawing, again, it may show a door or a window type in the drawings, but then the specifications call for something completely different. Or maybe it's a floor finish. The floor finish schedule may say porcelain tile, but then when we look at the specifications, there's only written language in there that specifies ceramic tile. So that type of disconnect creates massive confusion during construction, and it can lead to a lot of back and forth between all parties trying to figure out what the correct answer is. Or something that can also happen that's pretty dangerous is the contractor may not even bother bringing this disconnect up to anyone and just purchase whatever they feel is needed or would work for the project, and then install the wrong thing. So I've also seen that happen, and that's something that we definitely want to avoid. So another example, something I've been through is I worked on a project where the wall types on the drawing, the wall sections had shown 1-hour fire ratings, but the door specifications for those walls did not include language about requiring fire-rated doors. So thank goodness the contractor caught this and brought it to my attention before actually ordering the doors, because we would have had some serious issues if we had some unrated doors being installed on a firewall rated wall, a required fire rated wall. It wouldn't have met fire rated requirements, and it would have led to issues during inspection, or even worse, it could have led to a safety issue and risk the building occupant's safety. So how to avoid this? The solution is simple, but it requires a lot of discipline. You need to cross-reference your drawings and your specifications during the document preparation. Make this a habit to check every material or system shown in the drawings and check it with its corresponding specifications and vice versa. So for complex projects, you may consider having a third party review the drawings and specifications. Sometimes a fresh set of eyes can catch inconsistencies that you may miss when you're just too close to the project, too invested in it. You might not see these things. It can also be a third party review, can also be someone else in the office who may not be working on this project. Again, it's having that fresh set of eyes look at these documents. They can help to identify and call out anything that may be confusing. My favorite way to cross-reference drawings and specifications is to actually create a simple spreadsheet where you have two columns, one that is listing out the drawing and then one that's listing out the corresponding specification section. Use this as a checklist before issuing documents. It takes a bit of time up front, but it saves a lot of time and a lot of headache later. In our ARE bootcamp, Michael teaches this concept early on. He has bootcampers learn about specifications and drawings coordination right at the beginning of their ARE journey, rather than waiting for the technical exams and rather than waiting to take the PDD exam to learn about specifications. We start teaching them to bootcampers and teaching them the importance of specifications early on. We've seen way too many candidates taking the exams make the mistake of thinking that specifications are something they can learn last, when really understanding the coordination of the specifications and the drawings is a fundamental to every part of the practice of architecture.
You're listening to the Architect Exam Podcast, your guide to passing the ARE.
Hey there, this is Michael, and I have a quick favor to ask. If you're finding value in this free ARE podcast, please take a second to follow, like, subscribe, and leave a review or a comment on whatever platform you happen to hear this podcast. Your engagement lets us know that people are actually listening, and it inspires us to keep creating more podcast episodes. But honestly, what matters most to me isn't the likes or the follows. It's sharing this podcast with others who need it. When I was studying for my exams years ago, I felt completely alone and everyone was hoarding information instead of helping each other out. And it was that frustration that led me to start Young Architect back in 2014 with a simple mission: help the next generation of architects become the most successful generation of architects. So please share this podcast with your colleagues, friends, or anyone tackling their AREs. By sharing knowledge, we all rise together. All right, back to the podcast.
All right, so next up we have mistake number 2, which is ambiguous or unclear language. So ambiguous language, what do I mean by that? Well, this is honestly the most stealthy mistake because it's so easy to make without realizing it. You've probably heard ambiguous phrases before, something like high quality finish or industry standard installation, or my personal favorite, as required. These are vague terms and they force the contractor to make assumptions that rarely align with what we actually intended for the design. So I remember being on a job site once and during my walkthrough, saw some things I didn't really like and I brought it up to the contractor. This isn't what I specified, only to look back at what I had specified and realized I had written language that said premium grade, right? Which it's kind of vague. What do I mean by premium? So to the contractor, what they had installed was premium, but it wasn't premium to me. That was a pretty uncomfortable conversation to have with the contractor, which what they thought was premium certainly wasn't by the standards that I had intended for the project. So the solution is to be very specific and use a measurable criteria whenever possible. So instead of saying premium or high quality finish, you would have to say something very specific. For example, let's say we're specifying a high quality paint finish. We want to write into our specifications something closer to the exact way that it should be done, like specify 2 coats of semi-gloss latex paint over 1 coat of primer with light sanding between coats. That type of specific language conveys to the contractor the method that is expected in order to achieve that high quality finish. So a great practical tip for this mistake is similar to the first one, is to have someone unfamiliar with the project read over your specifications and highlight any language or any areas that they may find unclear. Because if someone unfamiliar to the project is reading your specifications and they can't really understand what you mean, I'm certain that the contractor won't understand what you mean either. So remember, in specifications, clarity isn't just a nice to have, it's essential for getting the result that you need for the project. All right, next is mistake number 3, which is copy and pasting manufacturer specifications without editing them. So this is a very tempting shortcut, which is just copying and pasting specifications into a project without thoroughly reviewing, reading, and editing them and fine-tuning them to your project. And I get it. We're all busy. We want to just grab those manufacturer specifications that are available online on their websites, download them and drop them into our drawings or our documents. But the problem is that those manufacturer specifications are written in a way to cover all possible applications of their product, not just in the context of what we need for our specific project. So to give a quick example, I've copied and pasted manufacturer specifications before. I did it for a project that needed a specific special flooring system at the interior. I had downloaded specifications from the manufacturer, which had listed all types of requirements for interior and exterior installation. So when I dropped those specifications into my project and shared them with the contractor was confused because there was language about exterior application, and they wanted to know the method or the amount or what we were doing about the exterior. When I was thinking, we only have these flooring systems at the interior. What do they mean? And I had realized that I had forgotten to delete that extra information about the exterior application. We didn't need that at the exterior at all. So, this is an easy thing to avoid, that you could have avoided that confusion with the contractor all along. The solution is to carefully edit and tailor those manufacturer specs to your project needs. Take the time to read through the entire manufacturer spec and delete any irrelevant sections, and definitely add project-specific requirements and make sure it integrates with the rest of your documents. So a practical tip that I use now when I'm using manufacturer specifications is that I highlight all the sections that I know will need to be customized. I highlight them in yellow, and that way when I go to review them with my drawings, it is impossible to miss them during my final review. So trust me, taking those extra 15 minutes will save you hours of confusion and RFIs in the future. And in our CDT 101 course, we teach this as a systematic approach to editing manufacturer specs properly. We walk through exactly how to evaluate specifications, like what to keep, what to modify, what to customize, and what to delete just based on your project requirements. This is one of the most practical skills you can develop as a specifier. Okay, next we have mistake number 4, which is inadequate consideration of site conditions. So this is when you may fail to consider the local site conditions when specifying materials. And this is a big one, especially for architects working across different regions and different climates. For example, material that may perform beautifully in a climate in Arizona may fail miserably in Florida's heat and humidity. Or a roofing system that may be perfect in Michigan wouldn't maybe hold up in California with its UV exposure. So you really have to keep in mind your climate, the region of that project, and know that the spec and the language that you're using is adequate for that project. And I definitely learned this lesson the hard way working on a project here in St. Thomas in the Virgin Islands. I've vaguely specified, steel railings on a project only to have them installed and to show signs of corrosion very early on after installation, where I realized I should have specifically specified something that would have held up in this environment. Something that was marine grade, stainless steel, or even aluminum would have been way more appropriate, and we would have avoided having to do an expensive replacement. The solution to this mistake is to really research material performance in similar conditions to your project and to consult with local professionals when working in different regions. If the firm you work with works across different climates, consider creating regional supplements to your master specifications. For example, have a coastal supplement that automatically will update your specifications to something that's appropriate in a coastal zone, right? For example, metal components. So remember that materials, They don't work well just anywhere. They are really fine-tuned with where your climate, where your region is, and how they interact with their environment. So your specifications need to account for that. All right, mistake number 5 is using outdated master specifications. All right, so we're about halfway through our list here, and we have probably all seen this or may have copies of this in our own files. This is when master specifications that we've developed over the years, we've saved them and they've maybe become outdated. So oftentimes master specs or specifications will list codes or standard requirements, but codes and standards are always getting updated and changing. And so if you're not regularly updating your specification language to list the correct code or the most recent standard requirement, your specifications can become obsolete. So I've done this before too. I've reused specifications for a project that I had completed. The projects were similar, but the project that I had copied over was from 3 years prior. And since then, the energy code had been updated. And the building department actually caught this and flagged numerous non-compliant elements. And we had to really kind of scramble to revise our specifications in the middle of the review process in order for them to be, current and compliant with the recent requirements. So the solution to this is, a way to avoid this is to implement a regular update for your specifications, to actually schedule this and review your specifications from time to time to make sure that they're current. Make it a habit to review them every time there's a code change. Just know that you need to update your specifications as well. And even just in a way to stay organized, you can actually date your master specifications right there in the file name, in the file structure, or in the header of that file. You can put a date in the master specs to remind yourself when's the last time they were updated. Or you could even schedule it in your calendar, as an annual review, at least annually, if not twice a year. You can update your specification language to make sure it's current with code compliance. So think of your specifications as really like a living document that need regular care and feeding. And it's not something that you can just kind of set and forget. It needs to be kind of kept current so that they function well. Staying current with codes is actually a theme that runs throughout all of the courses that we teach at Young Architect Academy, especially the technical exams, PPD and PDD. We really emphasize that understanding current codes is not just important for passing your exams, but this is a practice that is fundamental to our profession and our responsibility as architects. So the next mistake is mistake number 6, which is poor coordination with other design disciplines. So not only are we coordinating our drawings and our specifications, but we need to coordinate those specifications with all of our consultants as well. So, our specifications, they don't exist in isolation. They need to work in harmony with our structural engineer, our mechanical, electrical, plumbing engineers. And when they don't, of course, you can imagine that conflicts will come up during construction. And I've seen this. It's a really easy mistake to make where there's projects that have architectural ceiling heights listed, but the MEP or mechanical drawings are actually listing a different ceiling height because of their ductwork or items that are running through the ceiling. So the two need to be coordinated so that they're saying the same thing so that the contractor and installation team aren't left to make their best guess. The solution is to implement interdisciplinary reviews and regular coordination meetings with your consultants and during the specification development process. Make sure that everyone understands how specifications, how they're interacting with each other, and how they need to work together in order to reflect the same information. So another tip that I've found that's very helpful is to create a coordination matrix, especially for very complex projects, where you can map out all the different disciplines and all the specifications that align with those disciplines and overlap with each other so that you can review them and make sure that all of these critical junctions make sense and are coordinated with each other. Remember, a building is an integrated system, and all of our specifications should reflect that integration.
You're listening to the Architect Exam Podcast, the official podcast of the Young Architect Academy.
Next is mistake number 7, which is insufficient detail in execution sections. So let's talk about what that means. The execution section of your specifications is when you specify how materials and systems should be installed. And this is often the most neglected part of specifications. Many architects focus on the products themselves, but they end up saying kind of vague language and vague guidance on how it's installed. So I've done this before. I've definitely done this. I've specified systems before. One time it was a waterproofing system that was below grade, and I was vague on the language, and I was vague on how the surface should have been prepared and how the flashing should have been completed. And what ended up happening was, after our project was complete, we had water infiltration on the lowest level. And this is something that could have definitely been prevented if I had very clearly written execution language in the specifications. So the solution is and the way to avoid this is to include step-by-step procedures for critical systems, especially those related to the building's exterior and the building envelope, especially with regards to life safety or anything that would have extreme consequences when it comes to a failure of executing properly. So my practical tip for this, again, is with regards to critical systems, you can ask a contractor with experience in this system or this building and product type to review your execution sections before you actually finalize those specifications and share them. Experienced contractors for special systems will often have insights into installation challenges, especially locally in your region, and they may be able to provide you with some insight on things to avoid and things to anticipate for what needs to happen in order for that to be installed well and correctly. But when in doubt, more detail is always better than less. You can have as much language as is necessary in order to give that step-by-step procedure for installation. I've never had a contractor complain that we were too clear in the specifications for what needed to get done. So just remember that more detail is better than less. And in our ARE bootcamp, we emphasize understanding execution details as a critical part to the overall project delivery process. Many candidates focus only on design concepts. Of course, design is a very exciting stage that all of us are very interested in, but we often forget that how something gets built is just as important as what gets built. So Michael has boot campers study not just what goes into specifications, but how those specifications translate to actual construction in the field. Okay, mistake number 8. This is the lack of clarity on substitutions and alternates. So this is a big one. This is when you see those words, those famous words in specifications, or approved equal. Okay, that's kind of open-ended. Without defining what an approved substitution or an approved alternate is on a product, that or approved equal really leaves it open for interpretation to the reader. And I feel that by doing that, we are definitely asking for trouble. So contractors will naturally propose less expensive alternates if they're given that type of language. And without clear criteria, it's often hard for them to evaluate what the actual intention was of that product. On one of my early projects in my career, I specified a floor finish that included or equal language without directly specifying what the expected performance was of that flooring. And the contractor proposed a substitution that looked very similar, but the performance wasn't as great, and it had half the resistance to wearability, and it wasn't as durable, essentially. So without me specifying that specific expectation of performance, I had very little to stand on to kind of reject this contractor's suggestion of an alternate. So the solution to this is to establish a clear criteria for an acceptable substitution and a defined approval process for an item. So when you want to use language that says or equal, always list a critical performance characteristic alongside it. That way, you're really requiring what that substitute or alternate must meet. A practical tip is to create a standardized substitution request form. These are available through CSI. This form will require contractors to provide detailed information about proposed alternates. This puts the burden on the contractor to actually come up with the criteria that, the owner and design team will review in order to approve it, rather than you having to kind of scramble to find all of that information to put in the specification. Using those standardized request forms will help put that work and that research onto the contractor instead. So remember, when using that language, the or equal doesn't necessarily mean whatever the contractor wants to use. It means equal in all important aspects, which you need to define. And this substitution process, we cover it through our CDT 101 course. We break down the CSI format and explain exactly how to write enforceable substitution requirements. And understanding the Construction Specification Institute's approach to this is a very powerful framework for addressing these issues systematically. Mistake number 9. This is the communication breakdowns between office and field. So even the best specifications are useless if the people actually building the project don't understand them or even follow them. I've seen this countless times. I've seen instances in which the field personnel were simply unaware of the critical requirements, all of that language that's buried deep into the specifications. A lot of people that have their actual hands on a project aren't aware of what those requirements are. On one project, I had meticulously specified a sequence for a waterproofing installation. I had done my research, done my homework, and I listed step by step, but the best practice in this location for this project, what the sequence should be. But when I visited the site, the crew was actually doing it their own way and had a completely different method than what I had stated and specified. So when I asked the foreman, they admitted that they hadn't read that section of the specifications. They weren't aware of the sequence, and they were just doing it the way they always had. So the solution to this is to really highlight critical requirement, critical procedures that you've definitely researched and understand well, and that needs to be conveyed to the team clearly. So don't assume that everyone has read and thoroughly understood every word of your written specifications. Definitely bring their attention to the items that are of the utmost importance. The practical tip that I'd like to suggest here is to creating a one-page document that exists at the beginning of your specifications. That is the specifications highlight sheet. So this document is going to break down major trades that need the most attention and extract the most important requirements. So this is kind of like an outline, just kind of like an intro to the fully written specifications that the contractor and their team can quickly look at and review. This gets much more attention because it's at the front of the specifications that's quick to reference to know that there's more language later on in the full written specs that should be reviewed. So keep in mind that specifications only work when they are communicated effectively to the people that are actually physically doing the work. So do what you can to make sure that that information makes it in front of the eyes of the team that are building the project. Okay, everyone, we've made it to mistake number 10, which is misspecifying sustainable materials and systems. What do I mean by this? This is when we're working on projects that have specific requirements about sustainability, whether it's a system or the actual sustainable materials of a project. So there's a lot of increased focus on sustainable design and green building certifications in a lot of projects currently. And this mistake is becoming more and more common. Specifications for sustainable materials require special attention to details like recycled content, VOC limits, and documentation requirements. So I've worked on a LEED project before where we specified low VOC paints, but I actually missed in the specification writing specifically the test requirement and acceptable limits in the specifications. So when the contractor submitted product data, it didn't clearly state the VOC content. I think that they had just kind of used something similar to, oh, this is what we've used before. And this submittal criteria was essential for us to fall into compliance for LEED. We didn't want to lose any of our LEED points, right? So the solution is to, when you have something that is very specifically geared towards sustainability, you need to specifically state it and make it very clear to the design and, well, to the installation team, really, to make sure it's followed. A lot of the green building and sustainable goals, they're also go hand in hand with a certification that's being sought out. So that language needs to be into the specifications in order for that to be achieved. So make sure your specifications don't just include the performance requirement, but also the documentation needed that specify that performance, that specify meeting that test standard, because that documents will often need to be turned in to achieve that certification. You know, if you're going for LEED certification for a building, all of that data needs to be saved and submitted, essentially. So a practical tip for being able to achieve this is to create a checklist. I love a good list. So you're going to create a sustainability specification checklist and link it directly to the certifications that you're aiming looking to achieve. So again, for lead projects, for example, map out each specification section relevant to that lead credit that you're pursuing. So remember that sustainable design isn't just about the intent, but it's about a verifiable performance and that data. And that, that specification language that you write should make that data and that requirement to achieve certification very clear. All right, we did it. Those are those 10 common mistakes that architects make with specifications. We made it. We've covered a lot of ground today. These 10 specifications mistakes, they may seem overwhelming, but honestly, awareness is the first step to avoiding these. So now you are already aware and therefore prepared to avoid these mistakes. The good news is that improving your specifications is one of the most impactful ways to improve your projects. Better specifications mean fewer RFIs, fewer change orders, smoother construction, and ultimately better buildings. If you're looking to dive deeper into specifications, I highly recommend our CDT 101 course, where we cover topics and much more in greater detail, all about specifications. Specifications are a critical component to all of our ARE 101 courses as well at the Young Architect Academy, and they're tested throughout the architect registration exam. I'd love to hear about your experience with specifications. I want it all, the good, the bad, the ugly. So feel free to drop us a line on social media or email us. You can email me at emily@youngarchitect.com. Your story might even inspire a future episode. So definitely, let us know and keep in touch. And remember that none of us were really born with all of this knowledge. Not all of us were born as great, perfect specification writers. It's a skill that you need to develop and practice over time. So be kind to yourself as you learn. This information isn't easy, but hold yourself to the high standard of being able to achieve this. Your project deserves it. Thanks so much for listening in today. And remember, keep designing, keep specifying, and keep learning. And don't forget to subscribe to the Young Architect podcast wherever you get your podcast. Leave us a review if you enjoyed this episode. And for more resources on specifications and other architectural topics, visit academy.youngarchitect.com and check out our CDT 101 course. Check out our ARE Bootcamp and all of our other offerings. We just launched our brand new website and learning platform in early 2025, and we are really proud of what we've built for all of our students. It's never been easier to access our courses and resources to help you in your architecture career. Until next time, I'm Emily, and thanks for listening in.
Thanks for listening to the Architect Exam Podcast. Ready to take your studying to the next level? Visit our online ARE Architecture School website at academy.youngarchitect.com to learn more about how we can help you. See you next time.